Okay, guys, this is a review of gases to the people that weren't in class and for 8 day, just in case, because we didn't go over everything that we were supposed to do. So for this slide, all you guys need to know is that gases are constantly moving. You guys do need to know these 5 rules. Let me go back. Let me go back. So this is KMT, which is kinetic molecular theory. Kinetic uh, means that it's always moving. So that's why we have this picture of the gases moving. This is just trying to explain how gases behave. So gases are always going to be in a constant motion. They're going to move in a straight line and collide with each other in a container. So this only refers to ideal gases. It also says that ideal gases are only mostly empty space. And they also want to say that pressure is caused when the gas particles hit the container. And for ideal gases, we also have to assume that they don't have any energy loss because they are kinetic, so they're always going to be moving. And if there is no kinetic energy being lost or no energy loss, that's why it's always going to be moving. And kinetic energy is going to go or is going to be directly proportional to temperature. So if kinetic energy is really high, that means that the temperature is also going to be really high. Oh, did not mean to do that. And then this was the ideal the simulation that we did. We did the simulation. If you were B day, we did it in class. If you were A day, this was extra credit. So if you guys notice that these are going to be the gas molecules and they're in constant random motion, and when they're hitting the container, it's going to cause the pressure. If I heat it up, notice that the pressure is going to go up, but also the temperature. And if I cool it, the pressure is going to go down. I can reduce the volume, which is the space inside the container, and I can make it smaller. So the pressure is going to be really high because there's not enough space for them to move. So they're just going to be hitting the container a lot. So that's that. Just if you guys wanted to see it, you guys can also watch these videos that are attached to the PowerPoint. KMT is not really that going to be that important in the quiz, but this is going to be very important on the quiz, which are going to be the laws. What I need you guys to know is that you guys do need to know, you guys don't need to memorize the laws, but you guys do need to know um, what makes each law special or what variables are being used in the law. So if you guys notice, these 3 laws have a straight line in a graph. So they all have a straight line in the graph. And notice that they are also all fractions. So they very much look the same. And the reason why they're going in a straight line is because all of them are directly proportional to the variables in the equation. So this one, Gay-Lussac's is going to be pressure and temperature are going to be directly proportional. Volume and temperature are going to be directly proportional. And in this one, volume and number of moles are going to be directly proportional. Directly proportional means that if one goes up, the other one will go up. So if pressure goes up, for Gay-Lussac's law, temperature is also going to go up. But for this one, Boyle's law, the weird thing about this law is that this is the only one that the line looks like a J. This is the only one that looks a bit strange, and it's also the only one that's not in a fraction form. This one is just them being multiplied like this. So if you see pressure and volume and they're talking about Boyle's law, or if you see a graph that looks like a J, that is going to be Boyle's law, and it's the only one that is an inverse, meaning that if one goes up, the other one is gonna go down. They are the opposite of one another. And do we need to memorize the formulas? No, we don't need to memorize the formulas. You guys just need to know how they look like and how to use them. We don't not, you know, guys don't need to memorize them, but you guys do need to know which one is which. So if you see volume and temperature, that's Charles's law. If you see pressure and volume, that is Boyle's law. Where is it? Pressure and volume. That's Boyle's law. This is also the only one that is an inverse. An inverse between pressure and volume. And then Charles's law. Charles, Gay-Lussac's, Avogadro's law are all gonna be directly proportional. You guys need to know what 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 value they're using. So volume and temperature, or what variable they're using. But just know that it's going to be directly, and also know how the graphs look like. And these are the other laws that we went over. What you guys need to know about each one is what goes inside of them. So, like for ideal gas law, pressure, P is for pressure, which is atmosphere. V is for volume, and the unit we use is liters. N is moles, number of moles. R is the ideal gas constant, which is this number. T is temperature, which is in Kelvin. Just know how to, well, we're gonna go over how to move them around, but just know what goes in each one. So if you know that T is temperature, and the only thing for temperature that I can put in there is Kelvin, you'll be okay. Also, just know what units go in each letter. So you need to know the units for each letter. And then if you want more information about it, you guys can read that. So this question is asking how to rearrange it to solve for T2. So a lot of the problems that we're having with this, or these type of questions, is that you guys do not know how to rearrange them. And the reason why you guys don't know how to rearrange them is because you guys don't know, you guys aren't very good in some math, like, because all of this is math, but also you guys, I don't know what parts of it you're not seeing, and then I don't know if you guys know that this is what the formula is asking for, but so in this formula, the problem that's asking on your part is can you make this be by itself? So can you isolate it? Isolate it so we can solve for it. So maybe the question is asking what's gonna be temperature 2 of what's gonna be temperature 2 after all of this pressure, volume, and temperature. The first one changes and everything. So they want us to solve for temperature 2. The thing is that the only way I can solve for temperature 2 is if I move this to the other side. So I gotta move P2 and V2 to the other side so I can have T2 by itself. But the thing that we're having problems is we don't know how to move these things to the other side. And the only way you can move this to the other side is by well, you can use the butterfly method. So already guys said the butterfly method. We can't do the butterfly method on this one because we cannot do the butterfly method. We can do it, but after, the only way we can do the butterfly method is if we move this T2 to the top. So it has to be on top. It can't be on the bottom. So what I'm going to have to do is I'm going to have to flip them. And by flip them, I mean everything that was on top is going to go to the bottom, and everything on the bottom is going to go to the top. So what I'm going to do is T1 is going to go on top, and then P1 and V1 is going to go on the bottom, and then I'm going to do the same thing with the other one. It's going to look like this. So I switched everything. And now I can do the butterfly method. So I can cross multiply. So it's gonna look like this. P1, B1. So it's gonna look like that. And then I have t by itself. Why do I want t by itself? Because we're solving for t. If you guys still don't know that these letters means multiplication, they mean multiplication. So what you guys are gonna do is you guys are going to be given numbers with units, and then you're going to put them in these spaces, these empty spaces. Well, in the letters, where the letters are. So this is going to be how I solve for T2, and then in the problem, all I have to do is plug in the numbers in the equation, and I get my answer for T2. Hopefully, if you're still having issues with this, I need to figure out why. In this one, they want us to solve for n. So n is number of moles. Hopefully, we know this. N is number of moles. R is the gas constant. This is temperature. This is pressure. And this is volume. You need to know what goes into each letter. So this is gonna be pressure is atmosphere. Volume is liters. Mole is just a mole. Gas constant is a specific number, which is 0.0821. And then temperature is Kelvin. We don't use Celsius. So you guys need to know what goes into each letter, like the other one. So the other one was a different formula, but they're still the same letters. And this one is asking us to solve for mole, so they want mole to be on one side. They want mole to be on one side. If you guys still do not know, pressure, all of these numbers are being multiplied by one another. All of these letters are being multiplied by one another. So the only way I can move something that is being multiplied is by dividing. The only way I can move something that is being multiplied is by dividing. So that's why I made you guys want some of the classes. So I gave you guys this example, and this 4 and this x are being multiplied by one another. So usually when they give you a problem like this, they want you to make the x be by itself. How can I move the 4 to the other side? I gotta divide the 4, but I gotta divide it on both sides. Once I divide, the 4 cancels out. X equals 5. That's it. In this one, it's basically the same thing, but we have to move the R and the T. If I do it on one side, I have to do it on both sides. Once I do that, the T and the R cancel out, and I have N by itself. So my formula is going to look like this. This is my formula. This is how I isolate N, or how I solve for N. And then I plug in my numbers here, I multiply, and then I divide by the R and the T. And that's how I move the N to the other side, or solve for N. Next one, it says, if a problem was asking for the pressure of C, how would you rearrange Dalton's law? So for this one, it's asking me to solve for the missing letter. This is super easy. Let's say, they gave me 100, the total is 100, and then, my missing letter, which is C, is X. So the only way I can solve for X, or the missing letter, which is C, I will have to add them. And then I will have to subtract. So because they're being subtracted, because they're being added, I have to do the opposite. So the other one, they're multiplying. We had it like this. So we had to do the opposite, which is divide. But on this one, because they're being added, we have to do the opposite, which is minus. So the last one, PC, is going to be X, which is 50. So this one's really simple. But if you're still not understanding how I did it, or if I'm not explaining it well enough, please let me know. Because I feel like this one's very simple. Okay, so now we come to the example problems. So these example problems are going to be very similar to the quiz, but I'm not going to tell you how. And what you guys are going to do first is you guys have to figure out what equation you're going to use. So we have all these equations, but we don't know which one to use. So one way that you guys can figure it out is by what they give you. So if you guys don't know that milliliters equals volume, that equals volume. This is our temperature. They put it in Celsius, but just know that it's temperature, and this is also temperature. So which formula did they give us that only has volume and temperature? It will be this one. So that's how you figure out what equation to use. So you don't have to like try and guess or think about it too in depth about it. Just go based on what information they give you and then go from there rather than be all, I don't know, overthinking it. Just don't overthink it. So based on what they gave me, I know that this is my formula. And what I'm gonna do is plug in the stuff into the formula. So it says you collect 750 milliliters of xenon gas. Well, let me start highlighting. Let me highlight. Okay. At 45 degrees Celsius, what volume will the gas occupy if the temperature is reduced to 20 degrees Celsius? So first thing is figure out what the equation is. So I already figured it out. We figured that out. Secondly, we gotta change our Celsius to Kelvin. So what I'm gonna do is I'm gonna do 45 plus 273. This is our formula, and my cat is eating my thing. And it equals Kelvin, but what's 45 plus 273? We've calculate this because you guys know that I'm not a calculator. 318. Next, 20 plus 273. 20 plus 273 equals 298. Okay. And then thirdly, figure out how to put it in a formula. So these two numbers, just based on how they wrote it, I know that that's going to be V1 and T1. So I'm going to do 750 milliliters divided by 40. Wait, not 45 because we're using Kelvin. See, I already messed up. 318 Kelvin. And then we're looking for volume of the second one. And then I'm going to put 298. This is one of the problems where you can do the butterfly method and just solve for the second one. So what I can do is do 750 times 298 divided by 318. And then it will give me volume 2 or x2. So that's one way you can do it, butterfly method. But you can only do it if the top one is missing. You can't do it if the bottom one is missing. If the bottom one's missing, you gotta flip it. Because you can multiply a missing number that's in the bottom. It doesn't make any sense. But you can also do 298 times 298 to cancel out the number in the bottom. And then it's still the same thing. So you can do the butterfly method or that one, depending on whatever you like to do. Most of you guys like the butterfly method, which is fine. And my answer that I got was for volume of 2, it's 702.8 milliliters. So that's gonna be my volume of 2. All I have to do is put it in a calculator, multiply these two, divided by 318. Next question. It says if a canister of nitrogen gas is 150 liters, contains 450 mole of gas at 25 degrees Celsius, what is the pressure of the gas? So first I gotta figure out what they gave me. So they gave me volume. This is mole. This is temperature. And this is pressure. So because they gave me a lot of stuff and they gave me moles, which only one question, one formula is gonna ever give me moles, and that is the ideal gas law. So it's gonna be this one. If you see moles in the question, then you know it's the ideal one. So what I'm gonna do is write my formula first. Figure out what the formula you're gonna use. So formula is PV equals nRT. And we're solving for pressure. So what I have to do is rearrange my formula so I have P by itself on one side. So I gotta move the V. The only way I can move the V is by dividing, because these are being multiplied together. Well, all of them are being multiplied, so I gotta move the V. And it's gonna look like this. And then thirdly, make sure that my temperature is in Kelvin, which it's not. So I'm gonna have to change it. This is my formula. Celsius plus 273. So I'm gonna do 25 plus 273, and I get, let me check. Need to put it in calculator. Plus 25. 298. And then after that, that's it. I just gotta plug it in. So this is my formula that I'm gonna use. Do not use the first one because we're solving for P. I'm gonna do 450 moles times R. R is a very specific number. It's 0.0821. So 0.0821. Temperature is gonna be 298. And then divided by volume, which is gonna be 150. Once you do that, all you have to do is put it in a calculator. So the most important thing to remember is that you guys have to figure out what the formula is. Secondly, rearrange it. Thirdly, convert temperature to Kelvin and then just plug it in. So do not use Celsius. We don't use Celsius. You gotta convert it to Kelvin. And then also, if you're gonna use this one's the only one that has the R constant, this R. So just look up what R is. And I'm gonna plug this into the calculator. Give me a bit. There's 450 times 0.0821 times 298 divided by 150. And the answer I got for pressure is going to be 73.39 atmospheres. I'm gonna clear it. Moving on to the next one. Oh, it's gonna be so easy. It says if a barometer reads 104, let me highlight stuff. Give me a bit. As if a barometer reads 1,460 torr and the water pressure is 115 torr, the hydrogen pressure is 12 torr, and the carbon dioxide pressure is 225 torr, what is the partial pressure of the final gas, oxygen? So I just give you guys a formula. This is where you just have to add and subtract. So my total is going to be 1460. And then the other ones were 115, 12, and 225. And then we want the missing one, which is oxygen. So what I'm going to do is I'm going to add the ones that they gave me. So there's 115 plus 12 plus 225 equals 352. And if some of you guys are doing it at home, like putting it in the calculator and I get it wrong, it's probably because I'm using my phone calculator and that calculator does not work. I'm telling you guys. 1460 minus 352. And then I get my answer, which is 100 or 1108. And that's it. All you have to do is add them together and then subtract what you got for the this side of the total. This is what you subtract from total. And that's how you get the last one. Okay, next. Okay, this is the last one. Yeah, this is the last one. It says a sample of carbon monoxide has a volume of 12.5 with a pressure of 1.6 atmospheres. If the temperature remains constant, what will the pressure of the gas be when the volume has a volume of 2.50 liters? Just by reading the question, if it says temperature remains constant, that means that there is no change in temperature. If there is no change of temperature, that means that it's not going to have a T. But they didn't give us temperature. So the equation, first figure out what the equation is. This is the one you're going to use, this PV question, this PV one. My cat won't leave me alone. Stop. This one. So this is a question, this is the one you're going to use. Secondly, we don't have to worry about Kelvin because there is no temperature in here. So all you have to do is plug in the numbers, but you have to figure out how to rearrange for pressure. So we want to have this by itself on one side. The only way you can do that when something's being multiplied is by doing the opposite, which is divide. And this is where you guys we're not understanding how to do this. But it's gonna look like this. And then all you have to do is plug it in. So I'm gonna do 1.67 times 1.25 liters divided by 2.50 liters. And then if you notice, these units cancel out, so we get just pressure. And then I just gotta put it in a calculator. So I'm gonna do 1.67 times 1.25 divided by 2.50. And I got 1.67 times 1.25 divided by 2.50. I got, hopefully you guys are putting this calculator. I got 0.835 atmospheres. That's what I got. So all you have to do is multiply these two and then divide by the one in the bottom. If you don't know that these, like putting it, these parentheses means multiplication, it means multiplication. And then I divide by the 250 and this is what I got. So also know these units, the SI units, know that pressure is in Pascal. Please know that. Know the graphs. Like I said, know the graphs. Know this very important information. At low temperatures, real gases deviate from ideal gas. At high temperatures, real gases deviate from ideal gas behavior. Note that. Know these vocab words. Know all of this. Know this. Know the difference between diffusion and effusion. Effusion is through a little hole. Diffusion is just gradual mixing from one another, but in infusion it goes through a little hole. You guys do need to know that. So that's about it for the review. What you guys are supposed to do is do the review, do some of the review questions. A lot of it most of the math questions are already answered for you, but try to do the vocab words, most of the other questions that are on the review because they will be on the quiz. But that's about it.